To securely send a message, you first have to encrypt the message so hackers can't steal your data. Normally, you would share a secret key with the other person that scrambles and descrambles your message. But what if you've never met? That's where public key cryptography comes in. The RSA algorithm gives each person a public key to encrypt and a private key to decrypt. Bob wants to send a message to Albert, but Jeff is spying on their communication. Bob first locks his message with Albert's public key that everyone knows and sends it to him. Jeff doesn't have Albert's private key, so he can't open the message, but Albert can. How is this mathematically possible? It's time to delve into number theory! The public and private keys are mathematically linked using Euler's theorem, but modified. If m is the message, then this exponent converts between encryption and decryption, so the private key derives from this exponent. When we first create a public-private key pair, we choose two massive prime numbers that only we know and multiply them to create the modulus n. This symbol is Euler's phi function that outputs the number of numbers less than n that don't share a common factor with n. This normally takes a ton of time to compute, but here's the shortcut. Since prime numbers don't have any factors and the phi of p is just p minus 1, we can also multiply phi's together. Remember that our modulus n is p times q, the product of two prime numbers, so therefore the phi of n is just p minus 1 times q minus 1. Now this is what makes RSA encryption so secure. It's super hard to find out the prime factorization of a very large number, so if the bad guys don't know what p and q are, even if he knows n, then it's almost impossible to find the phi of n without the prime shortcut, and therefore the decryption key. Now Albert can create his public key that he sends to Bob to encrypt his message, then Bob sends the encrypted message back and Albert can use n and d to decrypt the data. But Jeff can't because he can't create d without knowing p and q. Every website, email, and even Bitcoin use RSA, and it's almost impossible to crack with large enough numbers, at least until